Hi everyone, happy Friday, and today is our next session in the series of talks about different things in terms of UK engineering community. And today we will talk about GraalVM and Spring Native. Level of talk will not be very high, it is just an introduction, so that I do not expect anything complicated today. Just as ordinary, a few words about myself. If you're watching this talk in the recording, I'm Alexander Barmin, Chief Software Engineer. I've written Java since 2010, but I suppose I've been reading Java even before that. So at least 12 years after this moment. I have a couple of certificates. If you want to ask something, do not hesitate to contact me on Teams or by email. Let's start with an agenda, what we will talk about today. We will talk at least a little what is GraalVM, how to build a native image with GraalVM, what we have in Spring Native, and what do you need in order to start using it. I have a few slides, but mostly it will be a live coding session. So we'll be ready, we will compile. So, what is GraalVM? On a very high level, GraalVM is a high-performance or high-performing JDK distribution developed by Oracle, and in common, it consists of three main parts. First of all, of course, it is JVM itself. It is GraalVM compiler, so that you can take your own Java code and compile it using GraalVM compiler. And next, at the end, you will get, well, whatever you ordinarily get. You will get bytecode you can run. And also, what is more important here is that it is a special kind of VM which allows you to execute not only Java, but also JavaScript, Ruby, Python, R, WebAssembly, and multiple languages at once. So you have application written in Java and another part of application written in JavaScript. You can run both of them together. It's ordinary. However, the most interesting part of it is native image compiler. So let's start with the very beginning, where you can download your GraalVM. And let's start with a very simple thing. We will write simple application and compile it with GraalVM, next run, and that's all. So what I suggest you to use in order to get GraalVM, of course, graalvm.org website, you can go here and download. Also, there is another option, maybe a little more convenient, is to use a SDK-man. SDK-man is a fantastic tool which allows you to manage development tool installed on your PC. For example, I have SDK installed, and when I open my terminal, I will use terminal a lot today. SDK leads Java, it will show me all the Java versions which are installed on my computer. And for example, in case if I'd like to get a new GraalVM version, as you may see, I'm using version 22.002, but looks like 22.1.0 was released recently. What I can do is just copy paste and say SDK install Java and version I'd like to install. It says it is already installed. Java minus version says that I'm still using my correct JDK. So that my next step is to do a very simple thing. SDK use Java. And what it does, it changes environment variables for this current terminal session. So that I will have GraalVM as a default JDK in this shell session. If I open another shell session, JDK minus version, it will still say that I'm using correct JVM. If I use another command, SDK default Java, it will update Java versions for my system, for the whole system. This is the first thing. Let's start with a very simple application we're going to build today, we're going to run today. This is the hello world, right? I suppose everybody who start developing start with this hello world application. Example basic. It is here, my hello world application. As you know, in order to build hello world application using Maven, what you need to do is as ordinary execute Maven clean compile. And what you will get as a result in well, in the target classes directory, what you will have as ordinary compiled classes, and you can start executing them just by calling Java and full name of the class. By the way, as you may notice, we have already built our first application using GraalVM, and it works perfectly. However, you also may say that we built a very simple but ordinary Java application, and it will be correct because we haven't built a native image yet. And native image is the most interesting part for us because what is native image? Native image technically is executable, which is platform dependent, and it is built especially for your platform. If you run it on Windows, you will get an exe file. If you build it on Linux or macOS, you will have a executable file built for these platforms. It is platform dependent. You cannot take application built for macOS and run it on Linux. This is the first point. Second point is that it is AUT compiler, so that it means that there is a small difference, technically very not small, but significant difference between running Java application and building and running Java application and building and running native application. Because if you have a Java application, what it can do, you can say, well, I built my application, but today I'd like to add additional jar file right near it and change the class path in runtime, so that it will be possible to, for example, introduce additional modules or additional components to your application. AUT compilation and native images work in a little different way. It says that everything you have at compile time, at build time, is what you will get in your application. You cannot add anything else when you build your application and you'd like to execute it. Interesting. Good. In this case, in order to start building native images, what you need to do? First of all, you need to have GraalVM installed. As you may see, I have GraalVM. The next thing you need to do is to execute a fantastic command which is available in GraalVM only. It is not available in ordinary JDK distribution. It is GraalVM component updater. This component updater allows you to install additional modules for your GraalVM. As I said at the very beginning, you can execute your code written in Python, for example, on JVM. So that component updater allows you to install these modules. As you may see, I have a few modules installed already in order to execute this programming language on top of JVM. So as you may see, I have GraalVM, I have JS, and I have native image compiler. If, for example, I'd like to install it, for example, I do not have it installed already, what I will do is as ordinary execute gu install native image. So it will download necessary binaries from GitHub and install on your machine. As soon as you've done it, you may start building native images. And before we proceed, I'd like to demonstrate some specification of the hardware I'm going to use. As you may see, it is Core i9, 8 cores, 16 GB of RAM, quite powerful machine. And please note why it is working, but it is not so quick as it can be. It is not working as quick as it can, or as it would. Compilation, building of native images takes time. So what's happening while I'm talking about it? Compilation goes, and I'm building a native image from already compiled Java classes. In order to do it, first of all, like the first thing I can do is to execute native image, and next, as ordinary, I can provide the full class path and name of the first class I'd like to start with. What I'm getting as a result, as you may see, I get this executable file. 11 megabytes for simple hello world, not so small, right? Dev. But I can execute it, and as you may see, this time the application was started not in JVM mode, but this time it was started in the native mode. Of course, we are not going to build these native images every time using native image compiler from terminal. Of course, native image compiler will be used under the hood, but as ordinary, we can use tools we're very familiar with. And this is Maven or Gradle. As ordinary, we have plugins, for example, for Maven, and there are a couple of plugins, one plugin for Maven, another plugin for Gradle, which allows you to build native images during your ordinary, let's say, build life cycle. If you'd like to build a native image with Maven, what you need to do is add this plugin and add an execution. What's important here is to set a goal, build, because there is another goal, build test. And also there are a couple more things need to be done, at least this one. You need to set what is the main class of your application. As soon as you've done it, you can build your application from Maven as ordinary, Maven clean package -p native, because this plugin is configured only in my configuration only for the native profile. And what I will get as a result, as ordinary, my application will be compiled by Java first, and next native image will be built. So result will be the same. As you may see, build consists of a few steps. So there are 7 steps, and first of all, native compiler analyzes what classes are available right now, building the closed world universe. Next, it tries to understand what exact methods will be invoked, and so on. And right after that, it compiles into the native executable. And as you may see, as a result, I have a hello world app in my target directory, exactly with the name I set here. It works. Hope it works. Let's move forward. Well, if we have a closed world, and it means that everything which is available during the build phase is exactly what will be available in your application. So that you cannot extend your application, right? Right. But we also have another situation. We know that Java is quite dynamic language, at least up to some extent. We have things like dynamic class loading, we have things like reflection, dynamic proxy, GNI, we have serialization, deserialization, and unfortunately, in order to perform all these operations, like dynamic class loading or even reflection, we need to provide GraalVM with additional information. For example, if you'd like to load class from our class path, what we're going to do as ordinary? As ordinary, we're going to write a code like class for name and provide name of the class, right? Right. Let's take a look into example like this. My next example will demonstrate you another important thing. Let's take a look into hello world application written in the enterprise way. So as you may see, it is still hello world, but as the first parameter in the command line, it receives a name of the class. Next, this class will be loaded using class for name. Next, I'm taking the first declared constructor, and next I'm casting my my new instance of my class to the supplier, and this supplier returns me hello world. Enterprise way of writing hello world, right? Right. And next, what I'm doing, I'm taking all the declared methods from this class and providing their names. If I run this class in the JVM mode, as ordinary, I'm compiling it. Everything is working as expected, as you may see. Instance of class has been successfully created. Everything is working, and so on. It works because I have already created configuration for this application, and in this configuration, I already have name of the class to be loaded. Everything seems to be fine. One single change I want to do, this one. What if I built a native image for this example? By the way, if you have any questions, please do not hesitate to clean page -p native, put them into the chat. If you do not understand something, also please do not hesitate providing this information into the chat. So what's happening? Everything as previously, but this time I'm building a native image with code which is using reflection. As you may see, everything seems to be working. My compilation goes fine. However, here you may notice, oh, not yet noticed. You may see everything completed successfully. Let's go to the target directory. In target directory, I have my hello world application. It says that I need to provide name of the parameter and say, well, buddy, I cannot find your class. You see? Okay, there is one more thing I want to show. Maybe, I switched it in a different profile. Yes, sorry, I need to rebuild my application. We have to wait a few more minutes because there is one more important thing to demonstrate. Well, native image compiler can work in two modes. First of all, it is ordinary mode and fallback mode. Ordinary mode says that everything which is available at build time will be included into your application, right? Right. And also it includes a fallback mode, which says, well, I see something will not be available. Something should be available during runtime, but not available at build time. So that I cannot, let's say, I cannot, as a build tool, be sure that your code will work correctly. And as you may see here, it says that, well, I see you're using class for name and class get declared methods. So that I will build not a native image, I will build a native image with fallback, which will include JVM inside. And in this case, as you may see, it says that, well, you built a native image, but this native image is not a real native image. It uses JDK, it uses Java runtime inside, and my hello world application in this case will work, but because currently it is built in the fallback mode. Well, as you remember, previously it was not working because I changed parameter for native image compiler, which says no fallback mode. Everything which is available on build time should be included into the image. Everything which is not available will not be included in my build image. Well, and you have seen that when we are not using the fallback mode, nothing is working. Let's try to fix it. And in order to fix it, we need to provide GraalVM with additional hints. What are the hints? These hints allows us to provide GraalVM with additional information, like during the execution, I'm going to access this set of classes using a reflection. So that I'm creating a file called the reflect.config.json. And in this reflect.config.json, I need to provide GraalVM with a list of classes I'm going to load via reflection. Why is it important? Because during compilation, it will read this file and include all the classes which are declared in this JSON file into closed world. However, it is not enough to provide only this reflect the dash config.json. It is also necessary to provide this properties file. In this properties file, let me start the build, and next I will explain what is in the property file. In this property file, I'm saying that, well, when native image compiler will build my native image, it will also use these additional arguments. You remember when previously oops, what's up? Native image, reflection config. Name of the file is different here. Let me change it. Op. You remember previously Java minus version, it is GraalVM native image. When I previously native image minus help, when I previously showed you native image command, it has multiple parameters. For example, you can add additional information like this is a list of, let's say, files and classes I'm going to access via reflection. This is the list of classes I'm going to serialize, and so on. In order not to write this long command line, native image compiler allows us to use this approach. It allows us to add all these parameters in the native-image.properties file, and here we can add as many parameters as we want. So we've built our image. And another important thing that this file native-image.properties should be in resources meta inf native image, next name of your group name and artifact name. So what I got as a result in the target, I get hello world. As ordinary, it is working. As you may see, this time we've got a different error message. Let's compare error message with the code we have. As you may see, it says class to be loaded. Class to be loaded is here. Next, it says class is loaded, and it is said class is loaded. But next we get an error because it says, well, unfortunately, I cannot access a method with name init, right? It means that, unfortunately, a class was added, but during compilation, our class was not provided with significant amount of metadata, and our runtime is not aware about methods which are available. Well, we need to make sure that our runtime is aware of it, so that we will provide runtime with and our compiler with this information. In order to do it, what I'm going to do is to add a few more lines here in the file. I'm adding name of the file, name of the method, and I'm adding parameter types with a list of parameters for this method. Why it is important? Because we all know that in Java we have method overloading, and we can have multiple methods with the same name but different parameters. In order to avoid this ambiguity, we need also to provide with exact parameters. Well, in order you not to be bored, because maybe you come here to listen to me about Spring framework, but I'm talking about GraalVM. Well, in order to understand what's happening in the Spring Native module, you unfortunately need to be aware of all these low-level details which are happening here in the GraalVM, because all Spring is doing, unfortunately, it is just providing us with a very, very convenient way of building these configuration files. Okay, let's run my application once again. Maybe this time I will get a different error message. And yes, as you may see, this time my class was loaded successfully. Instance of it was created, but as you may see, reflection do not have access to the list of methods available in my class. Well, we need to fix it again. And in order not to declare all the methods which are available here, what I can do is I can add a parameter which says query all declared methods equal to true. Query all declared method equals to true. It is here. And this time, when I compile my code, my native image, which is built, and my runtime will have access to everything. Let's wait for a moment, and let's see what will be the result. As you may see, even it takes some time even to build the hello world. Unfortunately, it works this way, but have nothing to say and can't complain. So let's try to do that. Hello world up and hello world works. So as you may see, this time we have access to the class, we have access to class constructor, and we have access to all class methods. Isn't it beautiful? You may say. I can say simultaneously yes and no, because on the one hand, we write an enterprise application, and this enterprise application is configured by JSON file. That's good. On the other hand, as for developer, I'm not very comfortable with writing JSON files. I'm very comfortable with writing Java code, so that I can change the configuration. I can change a way of providing GraalVM with all the necessary configurations. So what I can do, I can say that this time I'm going to write a configuration feature. Let's call it runtime configuration feature. And GraalVM provides us with fantastic thing called feature interface. In this feature interface, we can introduce some, let's say, some meta information during different phases of compilation. And for example, here I can do runtime reflection and register the class I'm going to access via reflection. Hello world provider.class. What else I'm going to access? Runtime reflection register for reflective instantiation. So here I'm allowing technically to use constructor of my class, hello world provider class, and also I'd like to register all the methods. Hello world provider get class get declared methods. Not correct. Okay, and what I'm going to do next, I need to change parameter here. And instead of providing configuration file, I can say that I'm providing features. And again, providing with a list of features. Building the application and checking that everything is working as before. So I see the message on my Teams. Unfortunately, it is not a message in our own chat, in the chat with us. Nevertheless, feel free to put your messages into the chat if you have any questions. Okay, my image is built. Target, hello world app, works. Hooray. Are you happy? I think so. There is one more thing, as ordinary. In order to write reliable software, what we need to do, we need to write tests. But as ordinary, we can say that even if test is running, you have already noticed that now we have to perform all the checks twice in the JVM mode and in the native mode. And in order to run our test not only against bytecode, but also against native image, we need to have a plugin, for example, or we need to provide a configuration. For example, in this case, as you may see, this simple test, which does actually the same, it loads class using class for name, next instantiate the class and execute the get method. It works in the JVM mode gracefully, but the next when we will compile it and run in the native image, it will fail. In order to run our tests in the native mode as well, we need to provide our Maven plugin with additional configuration. So as you have already seen, in order to build my native image during ordinary Maven build lifecycle, I'm adding build goal here. But what else I can do is that I'm adding additional execution with goal test for native Maven plugin. And what it will do, it will build native image and run my tests not only against JVM, but also against the native image. So as you may see, this time my tests are failing because, as you may see, class message provider test has failed because test message provider is not available in the native image because no enough configuration. Good. So let's get back to slides. There are a few things which you cannot make working in case if you're using GraalVM. For example, invoke dynamic is not working in case if you're dealing with GraalVM. There are some limitations, and security manager is also not available. Of course, because you're not running, let's say, your native images in the shared environment, like in Tomcat. You're running it not on, let's say, not on a bare metal, but at least as a separate process. Also, there is a list of features which work a little differently in case if you run your application in the native mode, like signal handlers, class initializers, finalizers, and so on. So, debugging and monitoring is also work a little differently in case if you run your application in native mode. Because my today's talk is very smoothly, I will not stress your attention on it. Just be aware that not everything is working. And let's move to the second part of the talk. So let's talk about Spring Native. Spring Native allows us to build our Spring application in native images using GraalVM native image compiler. And before talking about Spring, let me briefly demonstrate you a very simple Spring example I will use today. And next, start the compilation. So I'm going to start the compilation, and next I will get back to slides, because compilation of Spring application will take ages, unfortunately. Where am I? Oops, examples, Spring. Maven clean package -p native. So in order to create a new Spring application which will use native image compiler, what you need to do, if you have already seen at least one talk of George Long, you need to go to start.spring.io and start.spring.io and next choose native Spring Native experimental extension. But Spring Native experimental extension is not the one single thing which will be added to your project. There are a lot of things. First of all, of course, you're adding Spring Native module. Your Spring Native configuration module will be added. Also, by default, it will add Spring AUT plugin and Spring AUT for Maven and Gradle, if you're using one of them. Why these modules are needed? What's happening? You remember that we're talking about closed world, and it means that everything which is available at build time will be included into your native image. And as you remember, Spring does a lot of things at runtime. For example, you're starting the application, Spring scans your class path, load additional Spring Boot starters, evaluate your conditionals, create beans and register them, and so on. Well, unfortunately, right now, everything, almost everything from this list is not available. So you need to build your runtime, you need to build your closed world, you need to build all the classes in advance so that There is a separate Spring module called Spring AUP, which will be enabled by default. And what it does, as soon as you compiled your Spring application, it will go through your sources once, a few compiled sources once again. And based on them, it will build additional list of sources. And next compile them. What will be included into this list of sources? If, for example, you have complicated bin configuration, or you somehow configured your bin factory, it will be evaluated during compile time, and additional classes which perform this configuration will be generated. If you, for example, using conditionals also will be evaluated, and you will have an application which is built for one particular configuration. And next, of course, compilation will happen and native image will be built. So what is the application? As you may see, building Spring application takes ages, even on this computer. So it is still building. But what's the application I'm going to run? This is an ordinary, let's say, enterprise application with Spring Data GPA, Spring Boot Starter Web, and Postgres with Lombok and so on. And next, what I'm going to show you is an ordinary trick, which shows that, well, everything which is available in Spring works gracefully out of the box, and if you build native image for your Spring application, it will work 20 times quicker. Yes, that's true. It will work 20 times quicker, but you will spend ages just by compiling it. This is what Spring AT plugin does for us. It configures conditionals, it evaluates profiles, and invoke different bin definition registry port processors to create bin definitions at runtime declared at runtime during the compile time. So let's wait for a moment until my application is built. And while my application is building, let's take a look into the target directory, because everything interesting is happening in the target directory right now. My application, as I said, is simple and straightforward. As you may see, it is simple hello world application, does nothing, and implements application runner in order to load some data into the database on application start. I have a customer data model. This is a very comprehensive, complicated, and overwhelming customer description, customer name and customer ID. I have customer repository, which is provided by Spring Data JPA, and customer controller, which does almost nothing for me. However, what I want you to take a look into is to the target directory, because target directory this time includes a lot of classes. So what we can see here, we can see that during the build phase, Spring AUT plugin evaluated all the conditionals it found in my application and built for them these factories. So if you take a look into any, or let's say you will take a closer look into any into this code, you will notice that by default, first of all, what it does is just switching off some features of the Spring framework, like it switches off the ability to configure our application using XML. Also, it switches off Hibernate bytecode provider, and for every class, for every configuration we have, it configure our bin factories, our factories. For example, let's take a look here. Binding for Spring Factories loader. This is some code generated for loader. This is code generated for auto configurations, for example. If we take a look into, let's say, JDBC, we will have a configured factory which initializes our JDBC starter. So what happened here? By default, all this code, let's say, generated dynamically and executed during the startup of your Spring application. What we have now, in case if we're using Spring IoT plugin, instead of configuring all the beans during runtime, it configured all the beans in compile time. Instead of generating bean definitions by scanning a class path on the first stage of the application run, it scans the class path for Spring beans during the build phase and build a list of definitions. That's why it takes so much time. And also there is another important thing. Actually, you can use Spring IoT plugin even if you're not going to build native images. For example, in case if you'd like to reduce application start time for your ordinary Spring application, you will get some benefit of using Spring IoT plugin. Well, compilation takes ages. Let's wait for a moment. By the way, how are you doing today? How was your Friday?
Good so far.
Yes.
Yeah. Today is sunny. I hope the weekend will be the same weather. Yeah.
Yeah, I hope so. I hope so. So we're almost done with building the native image.
Yes.
Yes.
Oh, great.
Great. So we spent 8 minutes. You see, Core i9 to build a very simple Spring application, right? Right. So in order to run this application, what I need to have Postgres. And as soon as Postgres started, cd target, I'm starting Postgres in Docker ps, it is here, Postgres is up and running. This is my application, example Spring. Why? Customers does not exist. Okay, there are some limitations, unfortunately, so I have to run my ordinary version of the application. Why it isn't working? Relation customers does not exist. Oh, come on. I know why it is not working. I will explain you in a minute. It is not working because well, this is the first thing I noticed when I started building my simple Spring application as a native image. So it took almost 2.2 seconds to start my GraalVM version of application, and my native version of application started immediately. But you also noticed that I did some magic in the middle, right? I hope you were attentive. And what I did is I switched on this dependency. This is a very popular dependency to manage database migrations, to manage database schema.
Yes.
Liquibase.
May I make you just a very brief question? What do you think is better, Liquibase or Flyway? It depends. Yeah, good question. Sorry.
It depends. It depends.
Yeah.
It depends on what you're going to do. If you, for example, let's say, by design, Liquibase is designed to be platform independent. But on the other hand, Flyway is platform dependent because in Flyway you have to write plain SQL. In case if you sure that you will not change your database provider, you can use Flyway, because why not? In case if you have some doubts about it, or let's say really like to have a level of abstraction on top of your migrations, you'd better using Liquibase. So there is no silver bullet as ordinary. It should be chosen based on your requirements. I know I didn't answer your question directly, but I provided you with
No, it's a very clear question. Yeah, the difference is huge and it's clear. I mean, liquid base when you need to deal with something bit abstract that you don't know in the future, and flyway just if you know exactly that the B will be that one and so on. No, thank you very much. Thank you for explaining.
Good question. To be honest, it's a very fantastic question. And also, well, liquid base is not working. So what's happening under the hood if you're using liquid base? I hope you know it. If as soon as you added your plugin, this dependency is Spring Boot starter. It will create after configuration. After configuration, it will start some bins and so on. Majority of Spring modules already have this reflection config file in order to be built as native images. Unfortunately, as for now, well, it should be, it is not here, right? But let me take a look, maybe take a closer look. Unfortunately, as for now, for liquid base, there is no configuration for building a native image. And I know, for example, that Quarkus built their own configuration file in order to run liquid base in the native mode. But as for now, it is necessary to pay significant attention in order to run liquid base in the native mode. So that I excluded this dependency by default, and it is not included in my native image, but I can add it and run as my in the JVM mode. So as you may see, not everything is working good in case if you're using JVM, if you're using native image. Nevertheless, please take a look here. As you may see, my Spring application starts almost immediately if I'm using a native image. Well, let's try to do a little more advanced thing with Spring. And before doing that, I need to switch off my Docker in order not to waste resources. I'm very, very limited on that. And what I'm going to do is to write a fantastic thing which Spring allows us to have. It is bin post processor. Please raise up your thumb if you're a fan of bin post processors. Yeah, we will build a bin post processor. So what I have a fantastic service which is called my custom service, and this custom service is doing fantastic thing. It does something, and my implementation does something. Do very simple thing. It says hello world. Well, I'd like to be very sure that this overwhelming operation does not take a lot of time. So that I am introducing a log around method annotation. This log around method annotation does actually nothing. It is just a annotation with retention type runtime. However, in order to make it working, I written a very simple bin post processor. Before moving forward, let me switch to the project cd proxy and start building it because it takes time. Clean package minus bin native. And what my bin post processor is doing. As you know, bin post processor consists of two parts: post process before initialization, post process after initialization. What I'm doing here, a very simple thing. I'm checking that my class of my bin has log around method annotation on top of it, and if it has, I, instead of returning a bin here, I'm returning a proxy. It is ordinary JDK dynamic proxy, new proxy instance, and this proxy instance is doing the following thing. Before invoking a method, before invoking any method, it prints started at and ended at. Simple thing, but it works. So if I start my application in the JVM mode, you will see that it works. It works this way: started at, ended at, and hello world in the middle. Let's try to run this code using Spring in native way. I can say that it will not take 8 minutes, but it will take at least a couple of minutes. And while Spring is doing that, let's get back to slides and talk a little about Spring. So I have already said that Spring AUT does a lot of things for us. It configures bin path processors, it configures conditionals, it evaluates all the conditions in order to build everything during the build phase, right? Right. If you're familiar with other JVM frameworks, you may know that there is a framework called Micronaut, and framework called Micronaut does very similar things. Instead of using a reflection, it builds classes, it generates code during compile time. So that if you have declared a class with dependency to another class, instead of doing it at runtime, it will create a code during the build phase, which actually does this injection of one class into another. Code generation in Spring AUT is implemented in the very similar way. It scans your generated bytecode, and next, based on this bytecode, it generates additional code which will next perform injection and all other ways. So my application is built and cd target. Let's try to execute it. What I have, example, Spring proxy. This is my Spring application, and as you may see, it does not work, right? Right. But because why it does not work? Because it said, oh my God, you have not declared the proxy, right? It says, well, you are generating proxy in runtime, but generation of proxy in runtime is not supported. So that we have to provide our GraalVM, which is executed under the hood in Spring, with additional in Spring AUT and Spring Native with additional hints. And we have a few ways of doing that. The easiest way to do that is to put annotation native hint on top of any class which has configuration annotation on top of it. Let me do this, and while I will talk, I will show. So what it is doing. This native hint annotation is Spring annotation. It is captured next by Spring AUT plugin, and based on it, Spring AUT plugin generates for us in the target. I think we will be able to find it. It generates for us generated resources somewhere here. It generates for us native image. Proxy, it generates for us all these files. It generates configuration for proxies. My custom, it should be somewhere here, or may not. Okay. So what it does under the hood, actually, well, as I said, it generates my, well, hey buddy, where are you? Not this, dev. Okay, what it does, it maybe in another directory. Nevertheless, it should be available in build, during the build phase. Well, anyway, what it does, it generates for us these configuration files like proxy config, reflect config, .json, or resource config.json. And next, as soon as compilation completed, all this configuration will be captured by native compiler, and everything will work in runtime. This is only one way of adding additional information for Spring. While it compiles, let me get back to slides, because you see that type hint or native hint is not the best way of configuring. Why? Because you may notice that in my application, what I did is I declared an exact class which I'm going to proxy. Yeah, as you may see, I declared native hint inside JDK proxy and JDK proxy hint, and next I declared a list of types which I'm going to proxy. So that's for these classes GraalVM will know. but you know that it's quite tedious to put all these classes in the list here, so that we can get this information from Spring as ordinary, because Spring has all this information. Spring is aware of classes with annotations on top of that. Example, Spring proxy, and you see it works. So less than 1/5 of seconds it took to start Spring application. But it took how much? Almost 3 minutes to build. Well, let's move forward and let's try to make Spring help us to declare all these classes which have annotation on top of it. In order to do this trick, what we need to do, we have a couple of opportunities, and actually we have 3 opportunities. First of all, what we can do is to add a native hint. We have already seen it. We can add type hint for simple reflection if we need to have access to class methods, constructors, fields, or anything else via reflection. We can use type hint. But it is not enough for our case, because it doesn't allow us to go through all the classes which are declared in our configuration. So that we can have 2 more things. We can have native configurations in order to alter bin factory, quite complicated. And we also have bin native configuration processor. This is what we're going to do. So you notice that we have this bin post processor, and now we're going to write something like a native bin post processor. Native bin post processor. Because this native bin post processor will implement bin native configuration processor with 1 single method aside. And what it will do, fantastic thing. Instead of dealing with the bin itself, because during compile time bin is not available yet, we're dealing with bin descriptor. And from bin descriptor, we can take a lot of things. We can get a user bin class. This is the class of a bin as it is declared in my code. And also I can take a bin which will, and type of the bin it will be when all, let's say, bin factory post processor and bin post processors are applied. For example, if I have a bin which is generated for me by Spring, like JPA repository, user bin class will return me an interface, bin type will return me long name of the class generated by Spring Data JPA. So that here, what I need to do is to check that class I am declaring has annotation log around method on top of it. And what I'm going to do next I need to do a fantastic thing. Descriptor get user bin class get interfaces. I'm taking a list of interfaces. I'm going to proxy. And next in the registry, I'm registering my class for proxy. Native proxy entry of interfaces. This fantastic thing. It is and as ordinary it is not enough. As ordinary it is not enough because I need to register this class to make it available for Spring KUT plugin in order to make it next available for Graal. Everything you'd like to configure in Spring is done using Spring. Everything you'd like to configure in Spring Boot can be configured using Spring factories. Wrong name. Factories. And what I'm adding here, this. Yes, this is what I'm adding here. I'm adding, come on, please work. I'm adding this parameter. You remember, if you'd like to create your own Spring boot starter, what you need to do is to add the spring.factories file, and in spring.factories file, you need to add a record of type auto configuration. If I'd like to register bin native configuration processor, I need to add the record like this, bin native configuration processor. What will happen here under the hood? Again, the same thing will happen under the hood. In this case, Spring IoT plugin will find this information in the spring.factories file. Next, this class will be instantiated and executed. And this class will say that for my particular application, it is also necessary to register on the registry this any class which is in class path, in application context right now, which has a notation log around method on top of it. Quite complicated. Let's try to do it from the beginning. So during the build phase, Spring builds the whole context in order to understand what beans should be included there. And next, what it does, it passes all the bin instance descriptor through bin native configuration processors. And all these bin native configuration processors allow us to do something with our bins. For example, like in this case, if bin class of the bin has log around annotation on top of it, we will register our class in the native configuration registry to be proxied, and next Spring IoT plugin will generate all these proxy configuration JSONs for us. It looks a little hardcore like, right? But unfortunately, this is what we have to do if we'd like to build native images. Well, it will take ages. Nevertheless, we're almost done. And as you may notice, system monitor, it primarily consumes CPU. Oops, all done. CD targets. What's here? Example, Spring proxy. Oh, it works. Well, that's all from my side for today. Thank you very much for joining. You have already noticed that GraalVM provides significant performance boosts by converting existing content to native images. But you also noticed that it has a lot of limitations. You have to provide your native image compiler with a lot of hints, especially in cases when you're using dynamic capabilities of Java, like class loading or dealing with resources or anything like that. In case if you're using Spring Native will provide you with tons of after configurations and tons of things available out of the box. As you may notice, previously I demonstrated a simple application which has everything we have ordinary in our applications, like Spring Data JPA, Spring MVC, and everything was working out of the box without additional configuration. I just spent 10 minutes to build my application, but next it started in a supersonic speed, even less a second in comparison, and also it consumed significantly less resources. If you open the Quarkus website, you will notice that for Quarkus it is a killing feature to demonstrate that startup boot time is much less and memory consumption is again much less. I suppose when we are saying traditional cloud native stacks, we're comparing it with Spring, because Spring is very popular. And as you may see, yes, that's true. Even weight of the native image is small. Nevertheless, it requires a lot of time and a lot of compute resources to be built. So it makes sense to build it, let's say, on all these images on CI and use it from CI. If we're using Spring, everything seems to be working out of the box, but if not, Spring provides us with tons of points for extension. I have demonstrated only a couple of them, but I suppose for our smoothie talk, that's enough. As ordinary, all the code I demonstrated is available on GitHub, and there are a lot of explanation what's happening here. And if you're interested, you can fork this repository and go through all the examples I shown. Please. That's all from my side. Thank you very much for joining. Hope you enjoy. See you next time.
Thank you very much. Thank you very much to you, Alexander, and have a nice weekend too. You deserve it after this nice overview. Yeah, thank you very much.
I have some questions about.
Yeah.
I think so. My question is: does compile time increases exponentially, or how it increases because it takes very long?
Good question.
It grows exponentially, to be honest. Well, and let's say you have seen that my first Hello World consists of 3,000 classes. This simple Spring application, and it took maybe 20 or 30 seconds to compile. This simple Spring application, which does almost nothing, includes 15,000 classes, and it is necessary to spend 2 minutes to build it. So yes, it seems it grows exponentially.
Yeah, with a lot of traditional like service controllers, it will take a lot of time. Right. My next question is, so I noticed that sometimes when it's building, like you can see it on your screen, like it's building universe, it says like 4 GB for just building universe. Can it like exceed the resource to your machine and like do not build, for example? All right, here's my like enterprise application, it takes 16 GB, and it's like, oh, all right, I cannot build.
Yes, that's correct. That's true. Because of the few things. First of all, it is very, very memory hungry. That's true. And for example, for Spring, you know that we have Spring Boot. Let me, I forget name of the plugin. There is one more plugin, Spring. Yeah, we have Spring Boot Maven plugin, and Spring Boot Maven plugin allows us to build Docker images using build packs. I haven't showed it, but it is also possible to build Docker images with native executable inside. It is a very important thing. And it is recommended, officially recommended, to have at least 8 GB of RAM allocated for Docker in order to build your application inside Docker container, in order to build native Docker image. So it consumes a lot of resources.
Well, how do we build a very big enterprise application then?
Well,
sounds complex.
Yeah, that sounds complex, and a few ways of course available. I haven't demonstrated it, but it's possible to build application part by part. You can build, let's say, native executable from your dependency. Let's say you have a Spring stated JPA, Spring Boot Starter JPA dependency, and in order not to build it from scratch every time, you can build it as a native executable and reuse it. It is also possible. So you're building it bit by bit and next combine all the bits together. It's possible. And another way, of course, to build it in cloud, because in cloud you can get much more resources when resources available on particular contributor, on individual contributor's machine. So 2 ways, building part by part and build in cloud on powerful computers, on someone else's computers.
Right. Thank you. And my last question, how does it handle like multi-module projects? Is there a special way of approaching it, or it's like doing as always?
Yeah. No. Everything is ordinary. So as you've seen from the very, very first example, first we need to do is to build our Java bytecode. And next, from this Java bytecode, we will build a native image. In case if you have multi-module project, you will build Java bytecode all in one place. And next, from Java bytecode, it will build native image. I have not demonstrated, but it's also possible to build a native image from the jar file. You have an executable jar with main class declared inside, and so that it will build a native executable from this jar file.
All right, great. I don't have any more questions. Thank you.
Yeah, just long coming in mind, just last question, sorry. But in case, for example, you start a compilation, it takes, I don't know, 3-4 hours. If an error happens for any reason, we don't know, there is the possibility to use a flag, something like that, to recover what's the work that has done 3-4 hours ago before. No, I don't know, maybe. It's just a wish, but it's only a wish, maybe. Yeah.
At least I'm not aware of it. The answer will be I'm not aware of it. It was not mentioned anywhere in the documentation for GraalVM and specification for GraalVM because, yes, you're right. If compilation takes ages, it's better to avoid rebuilding the world from scratch. I do not know.
No, don't worry. But I suppose because I suppose if it exists such a feature, I think for sure they would highlight that one. So maybe it doesn't exist because, yeah. Anyway, it's a bit risky when you start a compilation. Anyway, it might be very good, very helpful if really you need it.
Mm-hmm. Yeah, you're right.